Hello guys, how are you all? Hope you guys are doing well. Welcome back to our channel Learn Maths with me. So today, before we start doing the problems or solving few sums, let us go through the daily life applications of our topic logarithms. So actually, what is log? Where are they used in our daily life? Who found log? And sometimes we tell log base 10, sometimes we tell log base 2. What are all these? While you might be aware of few of the answers, you might be unaware of few. So let's know them today. Okay. So what is log basically? Log in simple words is called as the reverse or inverse process of the exponents. Exponents in the sense anything written to the powers. B power x sometimes, or 5 power 4 sometimes, or any number to the power of something this is the exponential form. So what is log? How can this form be written in the form of logarithms? Suppose we say b power x is equals to a, then the logarithmic form would be log a to the base b is equals to x, where a is called the argument. Okay, so here a is known as the argument, and do remember that this cannot be a negative number, and b is called the base, and x would be the number. Okay, so now when we say b power x is equals to a, then logarithmic form would be log a to the base b is equals to x. For example, we take 5 power 4 is equal to 625. Then the logarithmic form would be log 625 to the base 5 is equals to 4. Now, what are we basically telling is how many times 5 is multiplied to get the number 625. So, logarithmic value tells us how many times a number is multiplied so that we get other number. Now, how many times 5 is multiplied to get the other number 625? It's 4 times. Hence, the log value, logarithmic form, log 625 to the base 5 is equals to 4. In the same way, if we take 2 cube is equals to 8. How many times are we multiplying 2 to get 8? It's 3, right? So logarithmic form will be log 8 to the base 2 is equals to 3. So this was basically invented to make our huge number calculations into simpler methods. So now, who's the father of logarithms? Who brought the concept, or let us say who found the concept of logarithms? It was John Napier, a scientist or a mathematician whose name was John Napier. He was the one who discovered this concept of logarithms in mathematics to simplify the complex calculations in mathematics. The log table that he made was based on lattice multiplication totally, and now after him many of the mathematicians have contributed to improve that log table, and now we use the modern log table, which is little bit improvised version of the one that Napier had discovered. So now logarithms with different types of bases, right? I have told you that there are logarithm with base 10, logarithms with base 2, and there is a logarithm with base e. So log with base 10 is the common logarithm. And this is commonly used in your scientific calculators, or let us say in the log tables that we use right now. And log with base 2 is called binary logarithm. This is commonly used in computer sciences. This E, the letter E denotes Euler's constant. And Euler is a name of a scientist or mathematician, whomever you consider. Euler's constant. So log E is the Euler logarithm. So these are the three common bases that we use to solve problems, different types of problems today in logarithms. So moving on, we might have gone through the properties of logarithms in the first video itself. Please have a check once again. So, by the life applications of logarithms, I mean where are the concept of logarithms used in our daily life? It is used in chemical sciences or mathematics or even computer sciences and many more. So, for an example, let's take chemical science. So, we refer sometimes that a solution is acidic, or sometimes we tell a solution is basic solution, and sometimes we refer that a solution is neutral. How do we decide if a chemical solution is acidic, basic, or neutral in nature? It depends on the pH value of a solution, right? So pH value is given by minus of logarithms of the H plus hydrogen ions. So we determine the pH value using this formula, which is based on logarithms. The pH value decides whether a solution is to be called acidic, basic, or neutral. Now we know that if a pH value is equals to 7, it's called neutral. And if it is greater than 7, it's basic. And if it is less than 7, it is called acidic solution in nature. So here we have one of the application of logarithms by which we determine the pH value and a solution is categorized to be acidic, basic, or neutral. The second example that I would give is the sound. We do like music, right? We do like listening music. We hear sounds every now and then from our surroundings. But sometimes we tell that the sound is very pleasant to hear, and sometimes we tell it's not at all acceptable, it's not at all bearable. How do we decide if the loudness of the sound or the sound intensity is bearable, pleasant to hear, or it is unacceptable? So it is depending on the decibel value of the sound, which is denoted by dB. This dB is the decibel unit to measure the loudness of sound. When a decibel measure increases greater than 85, you can see the pictures that are shown around. When a decibel value is greater than 85, it is to be said an unpleasant sound. It causes harm to our ears and it is not acceptable. When it is less than 85, it is said to be a pleasant sound. So a decibel value also can be determined by a formula which says log P2 by P1 base 10. 10 into log P2 by P1 base 10. So to measure the decibel unit or sound intensity, we do use logarithm. Okay. So third application of logarithms in our daily life is when earthquakes come into picture. Earthquakes. So how we hear that it is of 6.0 magnitude sometimes it is said it is 5.0. What is that? It's the measure or intensity of the earthquake that had occurred. How do we measure? Using it a Richter scale. It shows Richter scale magnitude 6.0. So, how are logarithms used? To find this magnitude itself, logarithms are used using, suppose we tell that the value in the Richter scale can be measured by log m to the base 10. Okay, for an example, if this is the formula, so the value of m is given as 10.6. Okay, so how do we measure the magnitude then? It is log 10 to the power 6 base 10, which is equal to 6. So hence we'll get the value, the magnitude or the value in Richter scale as 6.0. This is the range that we are told in the news when an earthquake is occurred in the terms of magnitude. So here, even here, to find the value, we use logarithms. These were only a few of the examples wherein we use logarithms in our daily life. There are many more. Now let's jump on to do our problems. Come on. So now we have log 343 by 125. By this form, do you remember any rule that we have discussed while we discussed the formulae? Okay, that is the quotient rule. Log m by n is equals to log m minus log n. So 343 can be written as cube of 7, that is 7 cube, and 125 in the same way can be written as 5 cube. So substituting 7 cube and 5 cube instead of 343 and 125. Log 343 by 125 now becomes log 7 cube by 5 cube, and I take whole cube to proceed further. Now log a power m is equals to m log a, that is 3 log 7 by 5. We have used log a power m is equals to m log a, that is 3 log 7 by 5. Now this rule comes here into picture. This can be written as log 7 minus log 5, because log m by n is equals to log m minus log n. That's it. Moving on to this problem. We have been given 2 log 3 plus 3 log 5 minus 5 log 2. If you remember a rule which says a power m is equal to m log a, using this we'll be able to solve. So we have been given terms in the form of m log a. How can be they written? Is a power m. So it turns log 3 square, applying this formula, log 5 cube minus log 2 power 5. Okay. Now log 3 square is log 9 plus log 5 cube is 125 minus 2 power 5 is 32. Now take this two terms as these are the terms for addition, and this is a separate term which will be subtracting later. Now log a plus log b. If you remember a rule which says log m into n is equals to log m plus log n. So addition now will turn into product rule, which is log 9 into 125 minus log 32. Log 1125 minus log 32. Now it's in the form log m minus log n, the quotient rule, log m by n, that is log 1125 by 32 is your answer for this. Yep. So this problem says solve 3 power x is equals to 5 power x minus 2. To solve this, let's take log base with base 10 on both sides, which becomes log 3 power x base 10 is equals to log 5 power x minus 2 base 10. Now, here we use the rule a power m is equals to m log a. So, it would become x log 3 base 10 and x minus 2 log 5 base 10. In the next step, let's multiply x log 5 base 10 minus 2 log 5 base 10. We are multiplying the terms separately and separating it. Now, bringing the x terms together, we'll get 2 log 5 base 10, putting the constants in one side and taking the variable x term to the other side. X log 3 to the base 10. So what I did here is, instead of taking this and making it negative, I took the constant term to the other side and brought this term to the right hand side. Now I'll take x in common. Minus log 3 to the base 10, and this would be 2 log 5 to the base 10. We would have to find the value of x, right? So I'll bring this term to be as the denominator to the other side. Multiplication will turn into division. So x is equals to 2 log 5 base 10 divided by log 5 base 10 minus log 3 base 10. Hope you guys would have understood today's video. As always, in case of any questions, doubt, queries, please do ping in the comment section and let me know. Meet you sometime in the next video. Till then, keep learning, keep enjoying.